This conference will now be recorded.
Very good evening, students. So, in continuation of this graphical problems from kinematics, we'll be discussing few more problems. So, let us start with the question shown in the screen. So, as I mentioned, this part is really very important, and almost all the competitive exam you'll see this kind of questions from kinematics, graphical questions. So let us start with this. The question says a particle starts from rest. Its acceleration at the time t is equal to 0 is given as 5 meter per second square at t is equal to 0, which varies with time as shown. So you can see this acceleration is actually varying with time, so it has a negative slope. Okay, that means acceleration is decreasing. The maximum speed of the particle will be, the maximum speed of the particle will be, so you can see the acceleration is actually changing. So let me write acceleration. We know acceleration is dv dt, right? Dv dt. Okay, now I have to find out the maximum speed. So dv is equal to a into dt, that I can write here. Okay, what we have to find out? We have to find out maximum speed of the particle. So time is increasing from 0 to 2, as you know. So okay, if we try to integrate this, so start from rest, let us just try to integrate this. Okay, at t is equal to 0, see acceleration is this much. At t is equal to 6 seconds, acceleration is actually becoming 0. Okay, so that is the thing. I think we have to okay, here both a and t are variable, so that's why there is a problem. Let us not go with this. Better to find out an average acceleration. Okay, let us read the question once again so that we can get some good clue. A particle starts from rest. Its acceleration at time t is equal to 0 is 5 meter per second square, which varies with time as shown in the figure. The maximum speed of the particle will be. So in this case, actually, you know, yeah. So let us see one thing here. See, uh, in case of velocity time graph, what we had seen, if this or this, whatever things are there, here the velocities are changing, right? Velocities are changing. So in such cases, how do you get the distance? We get distance from the area under the curve. So actually, we are doing the same, like proper thing here. So we have to do the integration. Integration means, see, dv dt is equal to dv dt, dv dt. So you know this dv a dt, okay, or we have to get the area under this curve, at curve. So velocity or maximum velocity will be, see, at this position acceleration stop actually, okay, the acceleration becomes 0. So the velocity will not decrease further at this particular position, okay. So the velocity will be maximum at this, excuse me, velocity will be maximum at this 6 second itself. Now velocity will be uniform from this particular time interval, okay. So what will be the area under this curve? Area under this curve is, look, half base into height. Height is how much? 5 meter per second square, so 5 meter. So this will be actually 15 meter per second. So this will be actually the maximum speed. Maximum speed of the particle. So guys, what we had to do, we had to actually find out the area under the curve. So this is the answer. Option 2 will be the answer for this question, okay. Let us go to the next problem, okay. So what is this problem saying? The problem says the variation of velocity of a particle moving along straight line is illustrated in the figure. The distance traveled by the particle in 4 seconds. So distance traveled here is v versus t graph, okay, v versus t graph. So here also, if you want to find out distance covered, you have to find out the area under the curve, vt curve. So look, I have this area, I have this rectangular area, I have this triangle plus this rectangular area. Like that, I have the whole area which I have to find out up to 4 seconds. See, up to here I have to find out. So look, the distance will be distance equal to, see, first I'll write for AOH, this particular triangle. So half into base is 1 into height, that is 20. Then this rectangle, so 1 into 20 plus this rectangle, this is 10, 10, 1 into 10 plus half 1, 10, half 1 into 10, okay, plus this part, this is 10 into 1. Now let us see how much we are getting. So this will give you 10 This is 20. This is 10 again. This is 5 plus 10. So 10, 10, 10. This 30 plus 20 is 50. So this is 55 meter. Okay, this is 55 meter. So option 3 will be the correct answer for this question. So these are not very tough questions, but we have to do the calculations carefully. Okay, now what is this question saying? The position time graph of a moving particle is shown. The instantaneous velocity of the particle is negative at the point. See, position time curve, position time curve is given over here. So what is velocity? Velocity is actually dx by dt. That means slope of the curve. So you can see between, see, at this particular portion, so this is positive slope. Here at d there will be actually no slope at all. This will be 0. Slope is 0. Okay, let me write. So at position C, positive slope, that means V positive. Okay, then during, okay, then D, at D, 0 slope. Okay, slope 0. Then E, at this position the slope will be negative slope, and F, the slope is again rising up or positive. So at the position E there will be negative velocity. Okay, at the point C, sorry, at the point E there will be negative velocity. So 4, option 4 will be the answer for this question. Okay, now these questions are very important, and these questions are thoughtful as well. So look, this question was being asked in JEE main or JEE. That time main was not the main and advanced, that concept was not there. But anyway, the JEE exam 2020, 2000, this question was being asked. A ball dropped vertically from height d above. So from here a ball is dropped. So this is d above, okay, above the ground. Here there was a ball, it was dropped actually. Okay, it hits the ground and bounces up vertically by d by 2. So it cannot go after, see, after bouncing, it is not going up to d, it is going up to d by 2, say. Okay, after elastic collision or impact from the, like, impact with the floor. So this distance is d by 2. Neglecting subsequent motion and air resistance, its velocity v varies with height. So we can neglect all other types of motion, and you can neglect the air resistance as well. Then what will be its velocity? Like how the velocity of the body will be varying with the height. So that is the question. Okay, so let us try to find out the or analyze each option. Let us start with option this D. So as height, see here you can see the arrows are different. That means, you know, initially the object was at d height. Okay, as it is coming closer to the ground, its velocity actually increases. That is very nice. That increases, obviously that increases. Okay, that increases. If I say this direction is, generally we take downward direction as positive, or if we take it is negative, the velocity is negative, then after dropping, you know, after hitting the ground, it will go in the reverse direction. So look here. But you know, the direction is, in this case, it should be positive, isn't it? If I say in the like towards the bottom it is negative, or the towards the ground it is negative, then when the ball is actually after impact or after the collision, elastic collision, it is going upwards, then the velocity should be positive. But here look, this is still negative, and it is becoming negative to 0 when it reaches to d/2 height. Okay, it becomes 0 when it reaches to d/2, but the velocity with which it is starting, it is actually given negative. Okay, so the velocity starts with 0 because it is dropped. Starts with 0, fine. Start with 0 velocity, then it is increasing towards downwards, that means negative velocity, that is fine. But when it is going up or rebounding, that time this should not be negative because the direction itself changes. Okay, direction changes. So that's why the second curve is not okay. Now come to this B. I'll discuss C later because these are kind of similar kind of graphs. I can see just the quadrant is different. So in this case, you look at d is equal to, like, at highest height, the velocity is given as 0. Velocity is 0, and then it is, as it is going downward, velocity increases. If I take this as positive, then see this point. Okay, if I say the velocity increases, but it is showing the decrease, right? It is showing the arrow is not exactly true. Okay, velocity should be, if I say this side is positive, this direction is positive, so the arrow should be going upward direction. Okay, because, okay, I see, I'm just dropping from height. Yes, I'm dropping from height, so the velocity is increasing as it go, or as it is dropping, as the distance, okay, as the distance increases, velocity is decreasing as the distance increasing. That is fine, but what about this one? As distance increases, it starts with this value, it should actually see that these arrows are actually having the problem. Okay, otherwise things should have been okay. This arrow, see, this is saying that when it is after impact it is, no, actually this is not showing the same thing. Okay, see, it is going from D to 0, velocity increases. I think the arrow should be this way, so this is not correct. In the second case, see, this is, see, after impact the height, actually height was 0, and then from 0 height it should be 0 height, from 0 height it should be going towards. So this arrow is also not true, or not all right. So these arrows are actually having problem. Okay, arrows are having problem. So that's why option B is also not correct. Now let us go to the C. See, in this case the question was, see, from certain height D it is dropped. Okay, when it is dropped, how will be the curve when it is dropped? See, let us find out this thing, relation between this. So b square minus u square is equal to 2gh. In this case, this, if I say g is minus, then minus gh. Okay, 2gh, and initial velocity 0, it starts from rest, suppose. So you can see that u square minus u square is equal to 2gh anyway. So if I take the mod of this also, so there will be, actually, see, v versus h, this curve will not be linear. Okay, because they have relationship b square. So b square is equal to 2gh. This relation, this is the relation. Now if I plot b and h, this will be non-linear curve, not linear. So but these are linear curve, so this is not possible. Okay, so the remaining is this one, first one, which will be the answer for this question. Let me just explain here. See, at particular height it was at D. Now it is just coming down, so velocity increases. But if I say the direction is in the opposite direction, let us take that. So that is minus, because you see here, so velocity is becoming maximum when it is reaching to the ground. Okay, reaching the ground, but in which direction? It is in the negative direction. But just after the collision, what happens? Just after the collision, the velocity changes its direction with certain minimum initial value that will not be 0 at that time. Now it is going upwards, but up to d by 2 it could go. Okay, and then velocity becomes 0. Okay, so this is actually the answer. Okay, so option A will be the correct answer for this question. Now let us go to the next problem. So this problem is also very interesting problem, and this has been asked in JEE Main 2005. I mean, that time JEE Main was not there, but JEE exam. Okay, this was asked in JEE exam. Now let us see this question. The given graph shows the variation of the velocity with displacement. See, look, this one. This is the velocity with displacement. Which of the following graphs given below gives correctly represents the variation of the acceleration with displacement? Acceleration with displacement. Acceleration with displacement. See, here it is given velocity with displacement. See, when displacement is maximum, velocity is becoming 0. And velocity is decreasing. That means, you know, the acceleration is actually, it is deceleration. This must be deceleration. Okay, A must be negative. That is so. That is what. Okay, I'm sorry. From here we cannot say anything. Let me just give you one. Okay, so we know v square is equal to initially, suppose initial velocity is 0 somehow, or here initial velocity is given already. So v0 minus 2ax, say. Okay, so when x is equal to x0, then v is equal to 0. Okay, x is equal to x0, v is equal to 0. Then x is equal to x0, this is 0. Then what we get, see, from here, 0, v0 minus 2ax0. So what will be a? Acceleration will be v0 by 2x0. Okay, this is the acceleration, I can say. Now the question is, what is the variation? Variation of acceleration. What is the variation of acceleration in this case? I see here it is actually v0 square. This is v0 square. V0 square. Okay, v0 square. Okay, let us try to understand, reading the questions once again properly. The given graph shows the variation of velocity with displacement. Which of the following graphs given below correctly represent the variation of acceleration with displacement? Okay, just a minute. Okay, so here if I look this graph is actually having negative slope. If I just take if I find out the slope here for this particular given graph, so I can write y minus y0, that is b0 with a minus sign, and x minus x0, that is x0 here. Okay, this is the slope actually. So what is the equation? Equation is for a straight line, this will be mx plus c, isn't it? And see, this equation is actually a straight line equation. Straight line. Okay. So if we see, if we try to find out dv dt, generally what we write this dv dx into dx dt. Okay, dt, this we can write some velocity. Okay, so a is equal to, see, if I write this dx dt as v, then dv dx, and now if I plot, okay, so this equation, you look here. Okay, so here for this we can write velocity v is equal to mx plus c. If we want to write that, then we have to write mx plus c. Okay, so we know v is equal to minus v0 by x0 into ax plus or minus c, right? This intercept is actually plus v0. Let us keep this here. So we'll get v is equal to minus v0 by x0. Okay, plus v0. This is the intercept c. Okay, this much is fine, I hope. So this is the equation 1. Say, let me clean the other portion. This portion let me clean, and see, we have to find out the relation between acceleration and displacement. Okay, so see, we had got a is equal to v dv dx. Okay, so here I have two things. You can see that I have velocity and displacement. Okay, both are in terms of variable. Now if I use this equation here, what we are going to get? if I write it here, V0 by X0 into AX dV dx. Okay. Okay, so just do one thing here. Let us try to integrate. If I try to integrate, what I get, AX, and this is v, v0 v square by 2, say v square by 2. Okay, no, this it is actually, I'm going off back. Let me try some other way. Obviously this is a really tricky question. So okay, so let us go with very beginning. Let me try once again with, see, m is slope, this is y by x, or changing the y coordinate divided by changing the x coordinate, so that is v0 by x0. So this is very simple. Now we have to write down this equation. See, y, we know y is equal to mx plus c. C is the intercept. In this case, c is actually v0. Okay, for this curve. Okay, now this means, this is v is equal to m is minus v0 by x0 plus v0. So this is fine from equation for this particular curve, velocity with distance. Okay, max, there should be some x also here. Okay, now we know a is equal to v dv dx. This we know. So how we are going to use this? Let us see. A is equal to dv dt. So from there I am writing this. See, if I put this value, somehow this v is equal to minus v0 by x0 ax. Okay, ax plus v0 into dv I see. So here, let me just do it once again here. One more step I have to do here. See, from here, if I write dv dx, what is this? dv dx is minus v0 by x0 see, if I just take the derivative of that, so I'll get this. Okay, this particular thing I'll get. Okay, now look, if I, okay, I don't have space here, let me make some space. Okay, so I have got dv dx is this much. Okay, so what is a then? A is equal to, so v, I'll write it here, v x0 x plus v0 into this dv dx. dv dx is minus v0 by x0. Now let us multiply this. So what I get? v0 square by x0 square x minus v0 square by x0. Okay, so this is what we are getting. That means, you know, if I try to write equation C in terms of y is equal to mx plus c, so if I write a is equal to y, sorry, a is equal to mx plus c, c means here, c means, or let us write it minus, doesn't matter, minus. So minus intercept, c is actually v0 square by x0. So there will be minus intercept but positive slope. Okay, minus intercept plus positive slope. Okay, we will have positive slope but minus intercept. So let me see from here which has minus intercept but positive slope. Okay, see the option A. If I just increase this, okay, if I increase this like this, then I'll get negative intercept. Okay, mx plus c, I'll get negative intercept. Okay, not this one, I'm sorry, this is not the one. See this guy, okay, this equation, this particular curve. Okay, so what we have got finally, you know, acceleration A is v0 by x0 whole square x minus v0 square by x0. So this is negative intercept but slope should be positive. So among this, which has positive slope, this is having negative slope. Okay, this is having negative slope. See, this also has negative slope. Okay, so you know there are possibilities with A and D because these are having negative slope. So this has negative slope, this has negative slope, but this guy has positive slope as you can see here. So this is positive slope. Okay, this has positive slope, and also this guy has positive slope, but intercept has to be negative. So in this case, you look, this is positive intercept, but this is negative intercept. Okay, so guys, you look, this is having negative slope, this is having negative slope. So this graphs I cannot say. Okay, this I can reject. I have A and D. Among this, see, this has positive intercept, but this has negative intercept. So option D will be the correct answer for this question. So let me just clean everything and show you the graph. So this graph is representing, so graph D is representing the correct variation of acceleration with displacement. So option D is the answer for this question. So that's why I'm saying these are really typical. We need to understand, we have to go sometime up to the mathematical end, etc., and then try to find out the answer. So here a body is thrown vertically upwards. Which of the following graphs correctly represents the velocity versus time graph? So velocity versus time graph, if a particle is thrown upward like this, what happens? Actually, eventually after reaching to the maximum height, it will have zero velocity at this particular position, and then it reverses its direction. But since the motion is under gravity, the speed further increases in the opposite direction. Okay, speed further increases in the opposite direction. That means the sign will be different. So see this having positive sign for both the cases. Okay, velocity is not negative. Here also velocity is not negative. So these two options I can actually reject. Now let us see, there is negative option here also, negative velocity. See negative velocity, see it is going to zero as time increases. Okay, so initially suppose it was given zero velocity, actually sorry, there was velocity given to the body while throwing, and as it go up and up, so velocity decreases, and at certain point it should be negative. It should be negative, and then but like at certain point it should be zero at maximum point, and then the velocity becomes, suppose if this side is positive, at this point it is zero, and then in the negative side it is increasing. But this is saying that when t is equal to 0, when t is equal to 0, you have thrown, so that time velocity was maximum. At certain time it becomes 0, and then velocity reverses its direction. But see how it is. At the same time, one more point I just wanted to say, that it does not start with the maximum velocity. Okay, it starts with zero velocity. Okay, it doesn't start with, see here initial velocity has to be zero, but here see in the opposite direction, but the velocity is starting with the maximum velocity, which is not true. Okay, which is not true. So it is starting at maximum height, it should not start with maximum velocity. Velocity will be zero initially. So option 1 will be the correct answer for this question. See how it is showing. See at t is equal to 0, when it was thrown, velocity was maximum, and then velocity starts decreasing at the maximum height. That means at a certain point of time velocity will be 0, and then velocity reverses its direction, but the velocity will be increasing linearly with g. Okay, with time, sorry, linearly with time. As it is under gravity, the speed remains the same actually in the opposite direction. Like from 0 it starts, then the velocity, actually magnitude of the velocity while going up and coming down as well, having the same magnitude, actually having the same, I'm sorry, not same magnitude, I should say it is growing in the opposite direction. That's all. It is growing in the opposite direction. Okay, it is growing in the opposite direction. And why it is falling on the same? Because see it is moving in a straight line. After changing its direction, it doesn't change further. Okay, Okay, now this question. All so let us start with this. Okay, so here the question says all the graphs are intended to represent the same motion. One of them does it. One of them does it incorrectly. We have to pick up the incorrect option here. So let us first start with this option A, what it is meaning. So this is velocity and position graph. Okay, velocity position graph. You can see here, if I just say that something is thrown in the upward direction, okay, thrown in the upward direction, so it is moving in the upward direction. As position increases, the velocity decreases, okay, and eventually at certain point it becomes 0. Now you know velocity time graph should be linear, but see velocity position time graph, see v square is equal to u square minus 2gh. If I say gh, h is the position, say it could be positive and negative select. Okay, so positive or negative. See if I take this is some intercept, okay, and see slope will be negative, okay, negative slope, negative or positive, that depends on like how it is taken, like whether it is falling from upward or it is thrown to upward, okay, depending on that the slope will be, and obviously this curve will be actually a parabolic curve, okay. So v versus h, velocity versus position curve will be a parabolic curve, okay, but with positive or negative slope, both depends on which direction you have, whether you have thrown it or you have dropped it. If you throw it, the slope will be negative. If it is coming down or dropped, if you drop from certain height, then the slope will be positive. So this is representing the motion as you see. This is actually constant acceleration or constant deceleration motion, okay, motion with constant acceleration or deceleration. So this is actually option A. What is option D? D we had just discussed, just in the previous slide we had discussed, right? So VT, this is also representing the same thing, like so you look this V dvdt is equal to A is acceleration, right? So now V will be A into T. If initial velocity is there, then there should be some intercept, okay. So this is the linear relationship, and see acceleration positive or negative, that depends whether the velocity will be negative or positive. Obviously, this initial velocity also should play a role in terms of giving it positive value or negative value. So V is directly proportional to T. Okay, that is your. And as I said, if it is dropped or like thrown from downward, so we have to take negative acceleration. Okay, negative acceleration. So the velocity decreases linearly. At certain point, at certain maximum height, the velocity becomes 0. Okay, at certain point of time there should be velocity 0, and then in the opposite direction it will increase. Okay, so B also representing the same thing. Now look this one, C. So in this case, suppose if this is actually position time curve. Position time curve. So we have to see with respect to acceleration. With respect to acceleration, we have to see. Let me write this position as x, 2ax. Okay, constant acceleration. So in case of position time curve, we know ut plus a half a t square. Now if initial velocity is 0, then I get half a t square. Okay, x is equal to half a t square. So you can see this also will be a parabolic curve. Okay, so x and t, this will be again a parabolic curve. Okay, parabolic curve. Therefore, C is actually also representing a motion with uniform acceleration. Okay, acceleration or deceleration, whatever you say. See this side, it is actually having positive flow. If this is position, let us see position. Obviously, here from here we cannot say that because t square it is. But anyway, so this would be a parabolic curve, so this is fine. Now the remaining is this one B. So B is actually a distance time curve. So in the distance time curve, how it will be? It will be just like this, parabolic. Okay, this should be parabolic. Okay, sometime it should be having positive slope, sometime it should be having negative slope like this, but it is not showing the same thing. Okay, so this is first of all not given as a parabola or parabolic curve. That is one point. So yeah, so it doesn't have positive. So it has positive slope, but negative slope is not that prominent. So you know this curve, like option D will be the like incorrect graph representing the same fact of uniform acceleration or deceleration. Okay, so position time curve will be parabolic actually. Okay, so that is where is the problem here. Distance time curve, position time curve, they will be looking similar. All right, now let us go to the next problem. This question says a particle starts from origin. What the question is saying? Question says a particle starts from origin O from rest and moves with a uniform acceleration along positive x-axis. Identify all the figures correctly represent the motion qualitatively. Identify all figures correctly represent the motion qualitatively. Question is that A particle starts from origin and from rest moves with uniform acceleration. See, this is acceleration time curve, this is actually velocity time curve, this is position time curve, this is again a position time curve. So uniform acceleration along positive x-axis the motion is. So you can see this has got a constant slope, so this has uniform acceleration. That is actually true and started from origin. That is also true from here, started from origin. Okay. Question: identify all figures that correctly represent. Okay, all figures, that means you should have more than one option. Okay, more than one. Okay, so B is, we can say, fine. Now xt card, we know, starts from rest and origin, so 0 plus half a t square. X is equal to it. So this is also expect like showing that constant acceleration or uniform acceleration. Okay, so this is also actually representing the same fact. So BD is there. Now you just check with this. So initially there is some displacement from here, we can see. So this is not starting from 0, not starting from 0. This is what I can say from here, origin, not starting from origin. Now look this one, AT curve. So A is actually not changing with time. So this is also representing uniformly accelerated motion. Accelerated motion. Okay, so in this I see this A, B and D, these are actually, according to me, these are A, B, D, which are yes, A, B, D. So these three are actually representing the same fact which is given, but this is not representing because it is having some displacement initially. Okay, it is not starting from 0, and moreover it is moving in the positive x direction, but this is having actually negative slopes. Okay, so that's why this C option will not be correct. Like this is not representing the fact. Otherwise A, B and D, they are all representing the same fact. All right, so okay, so I think this is, with this we will stop the class for today, and graphical problems we will complete with this. A particle starts from origin at t is equal to 0, as you see from here, moves along positive x-axis. The graph of velocity with respect to time is shown in the figure, what is the position of the particle at time t is equal to s, like sorry, t is equal to 5 seconds. After 5 seconds, that means at this particular position, like at this time, what will be the position? We have to find out what is the position. Okay, what is the position? It is moving in the moving. See, this is velocity time curve. That means, you know, it is uniformly accelerated motion. This is constant motion, A is equal to 0. Okay, and then what is this? Okay, sharply increasing. In the same direction, it is moving very sharply and reaching to this point. Okay, up to this. So to find out this position, you have to just find out the area under this curve. Actually, area under this curve up to this, area under this curve. So look, these are the thing we have to do. So you have to find out this particular area. Okay, this area we have to find out. Okay, then we'll get the answer. So what is the distance? Actually, we have to find out distance covered. Since it is moving along the positive x direction, so where the distance is, and it starts from origin. So if you find out the distance, that will be its position. Okay, so half into 2 into 2, half base and height. Then this much 2 to 4. So it has rectangular size. So 2 into 2 plus this particular part 1 into 3, and this is in meter. So 2 plus 4 plus 3. This is in meter. So 9 meter. So what will be the position of the particle after 5 seconds? It will be 9 meter from origin. Okay, it is 9 meter from origin. So option D will be the correct answer for this question. So with this, I'll stop it here for today. Next day, I'll take up some topic from class 12 and we'll discuss this kind of typical questions. Okay, so thank you for your patience. Bye for today.